Now just recording now. Just do some revision on 3.1. Do you still remember what I taught in chapter 1, 3.1? For a continuous function. Now for a continuous function fx. So if FA and FB has different size, you can see the screen? No, I can't make it bigger. Other than this, because the resolution is different. You know what I mean now? Now, if they have the different sign, then there exists a solution or root in between A and B. That's
odd number of roots.
Yeah.
Odd number of roots.
Not necessary. It can be even number.
It could be even if you want.
Yeah, it's odd number, but doesn't matter. At least one solution. So we don't do some exercise on this one now. This one is so easy.
Just sub it in.
Just substitute those values and then see to show that they have the different sign. That's it. So the next one is interval bisection.
Let me try a question.
So can you have a look at the now? We can what we do now is continue from 3.1. If you have find A and B, okay, A and B, and then what you can do again let's say FA is greater than 0 and FB is less than 0. I roughly draw a graph like this. A is less than B, okay? A is less than B. That means the graph should somehow look like this. May look like this one. That means there's a solution here at the green points. Now, if what does mean by interval bisection? Bisection, you know what does it mean? The cut in half. So let's say the midpoint is point C. Midpoint is point C.
Oh, F point C. You put F point C and you find the.
Now, so what you do C is the midpoint of A and B. That means A plus B over 2. Okay. And then you try to find FC. See if it is greater than 0 or less than 0. So if FC is less than 0, just like in this graph, that means the solution should be within A and C. If AFC is greater than 0, then the solution should be within C and B. Okay? That's how it works for the interval bisection. Now, can you read the example 3, okay, by yourself? Example 3 by yourself. Example 3. Have all of you get the new calculator?
No.
No?
Do we need it?
It's better. It's not better for core math, physics, or first pure math.
Even chemistry.
Even in chemistry.
Off Amazon.
Yes, I ordered and it will be shipped to the school on Monday. Coming Monday.
Hey, you don't have any more. So
Not yes. I don't have any more right now,
so popular.
and I get 10 more.
No, can I buy it?
Who do you sell it to?
How much?
Huh?
Who do you sell it to? Oh.
all the Form 5, Form 6, GCE, and IGCSE.
Drug cartel.
Do you understand the question 3, example 3? Shall we now? Let's say use an example in exercise 3B. question 1, okay? Question 1 is say that use this method to find the positive root for this equation. Correct to 1dp, okay, 1dp. So what should we do? First of all, let the function, okay, function fx to be x squared minus 7. Fx minus x squared minus 7. And then what do you think you should try? Now, I think no one is quite smart enough to try a non-integer number. That means with decimal place. So we start with integer first. So the x should be within which region?
1, 4. Yeah, 2 and 4.
2 squared is 4.
Yeah.
3 squared is 9.
Yeah.
So there should be a solution within 2 and 3.
Yeah.
But at least you need to show, although it seems like quite stupid to show this one. Okay. Now in the following steps, you can only ignore this part. You must write
The rest.
at least this one, okay? The rest, okay? You can only ignore the parts are highlighted. So, and then what you should say, you should say that there is a solution. In this region, okay, between 2 and 3. Okay, and then you use bisection. That means you check which number? 2.5. Okay, 2.5. So if you 2.5, what you get?
You just tell me only number.
A negative
Certain number that will give you
0.75. Now you can use the method in your textbook that is showing the tables. But do you think it will be quite troublesome?
That's a long time.
Yeah, it may take long time to draw the table. Now, or I use a simpler method to write it down. Now, I should, because I don't want to write so many words, I say that let alpha be the positive root, okay? So using some mathematical notation, I can simplify this statement already. You can say therefore alpha belongs to the set of.
what?
Do you know what this statement?
Oh, alpha is between 2 and 3.
Yes, it's include in between 2 and 3. Or you just say
Why
it's,
is it a comma? Shouldn't it be like different? Yeah, that one.
or like this
Yeah,
that's okay.
Wow. Oh. Then let's try the f2.5. What you get is negative value less than 0. So alpha should. And I think this one is more easy to read from the solution is more readable. The solution should within 2.5 and 3. Okay. And then what you should try next? 2.75.
Wait, why does it have to be 2.5 and 3?
So then, no, 2.5 and
2.5 is the midpoint of 2 and 3.
and then you find the other midpoint.
Yeah, I get that, but why is it above 2.5 and not below?
Because it's negative.
Okay.
Because this one is negative and this one is positive, it should be within these two.
If you draw it on a graph,
Draw the graph and then.
just draw a graph and you can like visualize it.
The next one then you you use your calculator. This one is positive. You should write down all the digits here. This is positive. So the solution should be within
2.5 and 2.75.
and then like you repeat the steps until you get the first DP does not change. Now let's go on. Okay.
Oh. Is there some way to just input it in your calculator?
You can basically create a formula in your calculator and just keep inputting it.
No. In the old calculator you can do it, but you don't have the steps, so it's not useful.
What do you mean like we don't have the steps? Oh yeah.
You need to write the steps. If you don't write you don't need to write the steps.
Yeah, we can like
You can find square root 7 and press N.
like no like it's gonna be faster in terms of like inputting the number. You don't have to input the entire thing that changes.
Or you can just check your answer, is it?
You can check your answer with square root 7, okay?
Yeah.
And then that's N. But you need to write the steps. So the midpoint of 2.5 and 2.75 is 2.625 square minus 7 and get negative value.
So the value that is closer to 0 is a higher one because of
Sometimes I don't like the method in the textbook because
They made a table and so
very difficult to read. I think.
it's basically that.
It's the same thing, but
You
it's
see,
just
every time they
complicated.
take out the midpoint and then add the function. Take out the midpoint, add the function.
Yeah. No, but I think this one is more easy to read.
Yeah.
Okay, and then let's try 2.625 plus 2.75 and then divide by 2
How many times you have to do this?
until you get.
Until you're just the first B2 did not change.
So here I think it's nearly done here. And then you get 0.3. If you want to be lazy, you can see it's just 3SF, okay? Because it's too time consuming to write down all the digits.
If I did this question in the exam,
You get the what?
It should be a lot of marks because it takes so much time.
I'm gonna say an ADHD exercise. I'm gonna actually do it.
no Gabriel has 10-minute break every 20 minutes.
No, you don't have break in normal lesson also.
Gabriel, he said Gabriel has
Oh.
an exam. He has a break.
It's a flaw.
So-
Shuts down.
And then you need to try next.
Keep going.
Almost done now.
So if you do it from 6 and 7 becomes something.
Yeah.
Going until it.
Yeah, until like the one BP is the same in both of them.
Is it finished? Finished yet? No, because if 2.65 and then you 1 dp you get 2.7. So if close to 2.63 and then 1 dp you get 2.6. So it's between.
Oh,
So the
you have to care about rounding.
Yeah.
2.7 and 2.6.
the first dp is not sure yet.
I think just one more time.
Efficient method to do this?
No.
Just do root 7
But-
find it out.
But in exam, of course, you don't need so many steps. I think it would design a question that does not require so much.
So we can just do like.
Sir, can you give us past papers?
Yes, given.
He gave her
Really good.
Given. Some of them.
first, like,
No, was that you?
yeah.
I don't have it, sir.
Okay. Ask me later. Ask me later on.
Let's pass
Yeah,
that
I
to me.
will do them.
So therefore, you know the final should be within.
Gee, I did wrong.
You gotta do it all over again, but
Times 25 like we're doing on my class.
Yeah, you got
Should we-
some snacks.
Oh, so sad. You need to do one more time.
What about this special snacks that
Oh, because it's
Okay, can I ignore the steps, okay? You know how to do it, okay?
Yeah. But then we won't have to present it this way in the exam. We can
In the
just do
exam, the
like-
question will not be like this.
Yeah.
You don't need to do so many times, I think.
You can just do like square root of 7.
Yeah. No.
until it's like it's hard to do the same decimal.
It's calculated.
FC is smaller than 0. FC is smaller than 0. CD.
FC is smaller than 0. Okay. Wait, pencil is better so that I can kind of show you visually.
So rather than rounding, it has to be equal about the rounding.
Like, if it's smaller than C and C is like below 0, so like the values between A and C. So that means if it's below 0, then it's between A and C.
No, only between 2 and 3.
Above
It's 4 and 8.
Okay, wait, I want to answer. If we're like smart enough, can we substitute in like 2.5?
Yeah, 2.6, 2.6, it should be the same.
2.5?
The
Yes.
other one has
Like
2.6,
exam, we
so
just
we'll run it
randomly
in-
does.
Yes.
FC's why? Oh, you don't have to pick them up.
if it's
No,
over
you
here,
do,
if
but
You
it's
can.
first step you can
if
do
it's above
2.5.
But it just save you one step.
below
Yeah.
0, then it's between A and C squared.
Okay?
Because what
It's
if I
not
could just
C
like
over
guess
here.
it? I'd be like, yeah, 2.6.
C in this case is
A bit
below
nonsense.
0. The y value is below 0 for
What if I
C.
just guess 1.6 and
Like
1.7
that.
and just see where I am?
No, a bit nonsense that you can.
That line goes above. It doesn't cross.
Okay, can you help me draw one?
So, you can remember.
Hey, can we go on?
Yes.
Okay? Lah. Then we finish this chapter, this session. And then we go to 3.4. The most important method. And 3.3 is linear interpolation. It's just if you watch the video, it's so simple. It's near about
Is that the formula LB plus
for 3.3 I just give you the concept but not doing some
No, linear interpolation is just one line and finding the midpoint.
not exactly the midpoint lah.
No, it's like x equals to 0.
Yeah. Lah.
So y equals to 0, right?
For linear interpolation. So it means like that. What are you doing?
I really do it.
So like just say there's a curve like this one. So FA is less than 0. FB is greater than 0.
C is
How can you use interpolation, linear interpolation to find a solution? It just assume there's a straight line passing through these 2 points,
is less than 0.
and then you find the
If it's less
solution.
than 0, it's over here. It's
Find
between
the
Oh, okay.
intersection point.
If it's more
Intersection
than-
point.
if it's
That's
more
it.
than 0,
So the what you can do that is that
than 0,
there are 3 points on the straight line,
Okay, I understand.
and then here is a root. Okay, let's say alpha. Okay, the root is alpha. You just find the alpha, given that the 4 numbers. I think you can do it. They are on the same straight line, so you can use the slope. These 2 slope equal to this one and this one slope.
Yeah.
Then you can find it. Okay. I don't want to. Just do some exercise or read the example by yourself. Let's go to 3.4.
Dude, we're doing it so fast.
No, this is from last week, the last lesson
Really?
that many of you are missing. Last lesson. Yeah.
When?
3.4 is the last session for.
I was here.
3.4 is the last session for this chapter, I think. So then later on we can do some chapter review questions. Now 3.4 is the Newton. I don't know how to pronounce it.
My white kid pronunciation, right?
And this method is a little bit related to the differentiation. You can see there's the differentiation here, f pi. So I just write down the formula here, and I'll explain it later on. I will pin the formula list for maybe formula booklet for you next time for all the chapters. I think this formula is given in the formula list as I remember long time before already. I already taken the exam long time before. Now this formula it seems quite difficult to understand, is it? Yes. N here n is an integer, so it means it's just like the this one, interval bisection. You need to do many times, repeating many times to get a more accurate solution. So while there is a f pi here, I draw a graph and then I can explain this formula. First of all, I need to rearrange this formula. I rearrange the formula like this.
Also, we skip
Finish already linear population. I told you this one. That's it. That's it. Here, this graph is all the concept in 3.3. That's it. And
we learned that in the kind of basic sense.
now this one. Now I draw the graph just like the graph here. I just change.
Would it be negative of that entire fraction?
Yeah, he just flipped everything to negative.
Oh,
he already put it. You skipped this.
wait. The pi should be in the bottom.
Yeah.
And then I rearrange a little bit.
Then he flipped everything.
So this form looks much like the form for the slope. So change in y over change in x. Okay? But y here is so it's the same as a minus 0 on in the numerator. So why it look like this one? Now xn is not 0, okay? If xn is 0, and then
It depends on the equation and when not.
fxn is not 0. If fxn is 0, and then you get fxn is 0. Now you look here, look at this formula. If fxn is 0, that means xn plus 1 equal xn. You don't need to do it again. You get the exact solution already. Because if you get fxn is 0, you get the xn is already the roots. So you don't need to do it again. So the xn here is not a perfect, it's just close to the root. So the next one,
What is this big X?
xn plus 1.
What was the x for? Where x stands for, like the function of x is like the formula of the line, and then the x is the point. The x coordinate here.
It means like what does it represent?
Which one?
Okay, what is this x?
X.
The x coordinate?
X coordinate.
Yeah, okay.
And then,
What's so funny?
no, x n plus 1. Now xn is your trial solution, okay?
Yeah.
Trial root, but it's not the exact root.
Well, you wrote the X so weirdly. Is it the same X as?
Yeah, that's why.
Now, normally I write the x like this because I don't want to mix it up with the multiple sign.
No, because okay, never mind.
So, now if you look at this formula, I draw the graph here.
Wait, so how do you get minus 0?
No. If I add minus 0 or not adding minus 0, they're same. It don't- if I write it down, it look much like the formula for the slope.
Yeah.
Oh, okay, I
This
get
F
it.
F prime is like if you find differentiation, then it gives the gradient.
If you go like this, what is that?
That's cool.
I'm not sure, but it's all coming together.
What?
What is that?
The universe is still expanding, guys.
Is what the second one?
No, it's not.
Yeah, come on, you can do it. Yes.
Now x naught here is the first child solution for a function. You try this number, see if it's 0. And then I draw another line. Now, if I put n to be 0,
Make sure that three different equations.
That's tangent.
Hmm?
That's tangent.
now, yeah, it's the tangent. That means the slope. Okay. Now, if I put n to be 0, then x1 should be the point at where?
Wait.
Now, f pi x naught, it means that the gradient of the tangent line, the differentiation, you have some idea, is it? The differentiation,
The tangent.
prime. Okay, this one is the gradient of the tangent line.
Okay.
So, if you look at this form, fx naught is this point. Fx naught is this point. So, can you notice where is x1?
But
the
so
root.
if it's a
yeah.
positive,
Oh.
then it should be lower. And if it's a negative, then it should be higher. No, wait, no.
No, I just want to ask you to know where is x1.
Where the red line on
The red
The red line,
Yeah, the red line.
yeah, I know. A red line is the line. Where is the point of x1?
crossing x-axis.
Yes, you know, can you understand why this point is x1?
Oh yeah, because it's at 0.
La, if you look at the form for the equation for gradient, y over 1,
Yeah.
y is f x naught minus 0.
Yeah, because it's all coming together.
So that's why that's
So many times.
I get it.
that's why I rearrange the term like this, and then easier to understand. So you can understand why this one, and then you can see x1 is closer to the root than x0. It's closer to the root. Okay. If you repeat this process, I use another color of the color here. So you use an light green line, and then this point is x2. Okay.
But how do you know where to draw the line?
The
Tangent line.
Tangent of where x
Tangent line.
is set. Oh.
And then if you repeat this process, and then you get a solution closer to the real solution. Okay.
So like the next one we choose, it has to be lower than wait.
Maybe I'll just give you one example. Okay. Do one example. But you can understand the idea behind this method. Okay.
Wait, what's the green line?
And the next,
Oh, you just repeat it.
yeah, repeating this process,
You get what? A root?
Yeah.
a closer solution.
Oh my.
Now, let me use the exercise 3D, the first question. Show that the equation fx naught has a root in the interval between 1 and 2. Okay? So for part A, you show that there's a solution between 1 and 2. So you put in 1, 2, therefore the solution is within 1 and 2. Okay? Done already for part A. It's just about 3.1. You get the idea, okay lah. For part B, for x naught to be 1.5, and then find apply this method, Newton method, okay, I just say Newton method, once to fx to find a second approximate to alpha, given your answer to 3 decimal place. So you just do this method once. So now you copy this formula. Now copy this formula, xn minus f xn over f pi xn. Now, and then the next step we want to find is x1, okay? Because you have initial one x naught is 1.5. Do you know how to do the differentiation for this function? I hope you can do it,
Differentiate the 3x
Okay. I think if you can't do, you should leave lah. But
differentiate is times and then minus, right?
Yeah.
So 6x.
Finding the
So you first
gradient,
times,
right?
then you
the
minus.
gradient.
Yes, you find the gradient constant.
Heavy left, is it?
Constant.
Huh? Harry does not continue FP. Oh, shh. Just
You can watch this later.
so let's kick him out the group.
Wait, can I have his textbooks?
Yeah, can I get his textbook? Can I say, can I borrow your textbook? And then I just keep that in the back.
Huh? I don't understand.
He's saying that if you're kicking Harry out, then he'll
Can I
just
just
take
steal his
Harry's
Oh,
spots.
okay, yeah.
Why are you kicking out?
No, he can't even handle the core mathematics.
Really?
Harry.
You can.
No.
I think he likes to just say, what?
No, last year too. In math, he's kind of dumb sometimes, but then he gets smart sometimes.
Yeah.
It's a
Quadratic equation.
He's a fool. He's like the sinus rhythm in a heartbeat.
Wait, where'd you get minus 2.25?
How does it?
Put in
Oh,
in the function, okay? So the final answer you should get is 1.51.
Yeah, you only differentiate
3 SF.
once.
3 decimal place.
No, this is the actual thing. You differentiated the differentiated one.
Oh, I need to reverse it.
Yeah, you need to integrate now.
Ours is getting such a good laugh out of it.
Just execute. Oh, wait, yeah.
Okay, 3dp.
Yeah, just that.
Differentiated it wrong.
Hey, chill out, man. We're trying to insult me then.
I see what I did now.
Now this is what idea in this method, okay? Not too difficult, I think, this chapter.
I just don't like them. I don't like chapter 1. I like this.
Give me time.
Sure, can we do another example? Wait a second. Wait, one second. Where did you get F1.5? From the
I don't
midpoint
like
of 1 and 2.
chapter 1.
My brain doesn't really
Oh, and you
Yeah,
do
I
it
need
for
to
both
understand it.
the prime thing, and then you divide.
My brain doesn't
So I'm getting 1.6 instead of 1.5.
Oh?
Man, your calculator is not working. You can't be wrong.
Oh, yeah, I find the wrong solution. 1.631, okay. 332. 1.632. 3dp. Given your question is 3dp. Now let's go on a difficult question and then let's end for today's lesson. Okay, for this question, okay, I think.
One more question. One more example.
Yeah.
You guys have been putting 1.5 into this, right?
Yeah.
Easy.
I'll just do one more question.
Which question?
Question
just go on to the next
5.
one.
Question 7.
Oh.
It's the most difficult one.
Yes.
Yes, I love this. Hey, which one?
Chapter review 3. This one. Chapter review 3. Show that there are 3 solutions. 3 rules, okay. How can we do it then?
Factorize.
No. It's so difficult to factorize. Now, if your character, and then first of all you
Cube,
go
polynomial 3.
your polynomial, and then all the 3, put in.
Yeah, I was like, I was 3 steps ahead.
I need to get this calculator.
And then all the roots are very not integer. Okay, one is 2.x something. Okay, one is 0.6, one is negative 0.5. So
So then how do you show it? It says show it, so that means we have to do reason.
So what you should do, you show that the sign will change.
Oh, 3 times.
Now the solution, one of the solution is 2.87. So you can try, let's say 2.5 and 3.
And 0.5,
Mm-hmm.
negative 0.5.
Alright, F2.
F3 and then 2.5, or is it too obvious that you use calculator if you try 2.5?
It's too obvious.
Do they care?
Can you get
You're
marks
getting the
deducted for that?
No, what did you
Too
just claim you're a
obvious.
genius?
You're too correct.
No, you can't.
Wait, so we can just claim we're a genius like I did then.
Okay, that means there's a root in between 2 and 3. Okay, another root is
Negative 0.5, so just put negative 1.
negative 1 and 0, maybe. And F1 and negative 1 and 0. 0 and F1.
Wow, you're using 5?
No, because there's 3 roots.
Mm.
It's between 0 and 1 and 0.
Oh,
and
yes.
negative.
Okay, I get it.
No, really.
Yes.
So there are one root in between 2 and 3, and one root in between 0 and 1, and one root between 0 and negative 1.
So which steps are we supposed to put in?
This,
All this?
just this.
So
Just
that's all the steps.
this.
So you go to the calculator to find where you need to start doing it, and then you just show F3.
Yes, you can do it. Now another way to do it,
Is there any way to do it without the calculator, or is it just all trial and error?
use the function of table in your calculator. Do you know? Menu, and then go to 9. Put 9 is table, and then plug in the function. Just like this one. Plug in the function. Table. No. The new character only.
Oh.
The new character only. Okay. Đấy là get it. Table. Yeah.
Just like I just got that.
GS. Forget. Okay. You can type in 2 functions together.
But I don't understand.
Yeah.
Which one?
Table.
Okay.
Plug in the function.
I remember like for DSC MP, like you need to have 2
Oh, yeah.
calculators.
Yeah, this one.
And then GX just ignore it.
You know Miguel?
0?
No. Yeah.
No, GX just ignore it. Just ignore it. Don't put a value. The table let's start. It means that the value.
Value is 1.
Let's say, but in this case you know it's negative 1. So if you put in that, let's say negative 10, and end at 10, step is 1, and then it will give you the value of the function from negative 10, negative 9, negative 8.
Oh,
to
like
10.
the frequency and then.
Damn.
Wait, what?
That's all the value.
Yeah, it's all the values of the function when x equal to negative 10, negative 9, 8, negative 8.
Yeah, you guys have.
Okay?
I don't even know what.
And then you can, like, you
Oh,
can,
like, okay, look. Negative 3.
G is what? G is 0?
Switch aside.
Do you just press enter when you pass it?
Let's go into infinity.
For this, right?
okay?
Okay, I'll buy one.
Then this step, now, given that if the function is very very complicated, This one can save your time to find the value of fx.
Wait, so, I understand the concept, but how do I explain to them? Do I literally just draw it?
No need to draw it. And then if you show that they have the sign chain, and that's it.
I only found one.
Okay, now
That's
just
it.
write down that and you
Yeah.
get the mark.
Just find two.
I only found
side
two
changes.
roots.
No,
So,
you just write that down and you get the marks.
Yeah.
I think this other way.
one over here.
I like that.
Oh, but
Two.
you have to do this.
And, oh wait, three. Sorry.
Like just say, and then you say,
So half the marks are from that.
I mean, like,
Oh,
it's
sorry.
in the answer.
Why didn't you buy them better ones?
I don't have $140.
That's natural.
now there are 3 rules. And the first, Oh. there are 3 rules. Let's say it's alpha 1, alpha 2, and alpha 3, okay? And then alpha 1 is between 2 and 3. Alpha 2 is between 0 and 1. And alpha 3 is in between left 1 and 0. Okay, that's it for this part.
What about B?
Let's go on part B, okay? Part A should be quite simple.
What is that? What is that?
Alpha 1, alpha 2, alpha 3.
What's that?
You know the N
The,
number.
what does that say?
No, nothing.
Oh, yo, who's this egg?
Yeah, part B, let's go on.
Mine is
Where's
X.
mine?
I got it from
It's the worst one. That's a low.
They made it in like 2 hours.
Mine's gonna take 6 days.
Wow. You have like dyslexia in your eyes.
Next part, use the Newton method to find the 3 roots.
Diamond question.
So, I would rather you can just from to start with, you need to choose a x0. That means the point where you start first. Here, x0. So to be more accurate, I think that you should choose 2.5. That's a midpoint.
Each of the roots, we have to do it 3 times.
Yes. So one is it's not like the public exam question. So try 0.5, negative 0.5, and 2.5.
The midpoint of each one of the things that we're
Yeah. The midpoint of each region.
Also, we
intervals.
have 3 and 2.
Yeah.
We do
Why do we need
1.5.
all those midpoints?
Because we need to prove it.
The midpoint should be more accurate. Now let's try.
Wait,
Yeah.
are we still doing the same
I thought it
question?
says
Yes.
But in
Newton.
the exam, do you need to have this part too?
Hmm?
Do you need to write this
Why don't we
too?
just use Newton?
Like which part?
The midpoints of these.
No need. You just
We have to find the midpoint.
given that the midpoint is within that region, that's okay. Given that the points within that region is okay. Now let's try x. Let's try the trial point is 2.5. Okay. Now what you get at x1 equal to 2.5 minus f2.5 over the derivative of 2.5. Okay. That's how the formula look like. This formula look. Yeah. Okay.
Wait, let me. X.
And then the function is x cubed minus 3x squared plus 1, is it? Yeah. This question does not say clearly how many times you should try
Wait, what?
before you end.
It says 2, 3.
No, you use the.
You showed us 3 different.
No, you
One,
use this
two.
one. No, this one.
What are these?
No, this is the same thing, but
What is
you
this?
can
Gradient.
convert it to that, and that helps you find the gradient. This is
So do we need to do
just it's the same thing. Just use this. Sorry.
Okay.
Sir, how many marks is this for?
Hmm?
How many marks is this?
Not sure. It's not exam type.
Dude, how is
Exam like question. So doesn't matter.
Dude, Jose is like the biggest time I just sit with every question. He's like, wait. How do you do that?
You know he couldn't handle Chinese.
Well,
He's Spanish.
I know, but foreign Chinese is so easy.
He joined Form 1, he didn't even know English.
Really?
He learned like a month.
He still doesn't know English. In, at, out. You always listen to him. I'm at the box.
Grades aren't. This is what you did to find like
So,
So what you find is 3.66,
3.066. And what's that? The
and
gradient?
then you choose this one.
So this is X
Yes, this is one.
La 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 la. La.
Wait, what is this? X
This
Hmm?
should be quite close to the real thing.
La, this one you should not choose this one because
Outside.
it's outside the range of 2 and 3. So sometimes this method will fail to get you a closer solution. That means maybe the solution should be close to 3. So why not we try 3? Because you know actually the solution is 2.87, 2.8 something. So we can try 3 instead of try 2.5.
But it works, right? Then you average 2.5 and 3.
27減18。
Wow.
You have to do this for 3 of them.
3SF, is it? 3 decimal place.
109.
So one of the solution will be this one.
No, that's
You should try 3.
9. Let me say.
Like, you know why it fails
Because like
initially
that's
if you try 2.5?
This is near the turning point.
Yeah.
No, this is 27.
Wait, so you need to do that for
So yeah.
3 x values.
Yeah, but this is not
Mm.
exact question.
It's not like
So this-
the exam question.
So he differentiated and then
Differentiating
Wait, what? I don't.
Yeah.
I just found out.
Oh, you're really slow. So wait, sorry, do we use this one?
Yes.
Why? It's inside.
This one is without the range, outside the range 2 and 3.
Yes. But what if there's a more accurate one?
It's this one.
Like you use 1 and
No, because you know the solution should be between 2 and 3.
Oh, so how did I know how to?
3.067.
It's outside 2 and 3.
I know. How did it do that? That's.
Because it's not.
So like if we do that and let's say we choose 2.5 because that would be the first guess, and if we get like 3.067, so do we just cross that working out or do we just
Like, can't we
just
do
continue with
2.5
x0 x0 we just
3.036?
La. Why I not try? Why I not using 3.067 to repeat the Newton's method?
Outside of a.
Because this one is already outside the interval.
So what
That's
did
not
you?
what I mean.
What did you use? then?
So why not choose 3? That's closer to the solution
Yeah,
already.
but then like do we have
You understand then why you ask
Just the
again?
first question is the first answer invalid, so you cross it out.
Yeah.
the first answer is invalid. So we
all
just
that
cross
work
our
for nothing.
working.
Yeah.
No, at least you know the solution is close to 3, then close to 2.
So instead of 3.06, if it was like 1.9, then you would put
How
2.
long I spent?
No, and then you use 2.
You use 2.75.
Yes.
I really enjoy this.
So what do we do with that now? We put it again?
Now you try 3 again instead of 2.5.
I don't
No,
want to.
the 2.889. Put
La. But because the questioner does not state clearly, so if the question asks you to find the obtain the roots correct to 1 dp, and then your 1 dp, the first dp should be accurate. So in this question, It's not very clear question.
We just make it 1 dp.
Because you read the question, give your answers to 3 decimal places. It's not asking you.
What is the back of the
Listen carefully. It's not asking you give your answer correct to 3dp. To know what's the difference.
Oh yeah.
If you ask you to find a solution, find the answer correct to 3dp, that means your 3 decimal place should be
Rounded
accurate.
up or down.
accurate,
Oh.
as same as the solution. So in this question, it may just ask you to.
So you can just use it. So one of the answers is just 2.8.
Yeah.
So we need to do the same thing for the other two.
Yes.
Oh.
Will all these questions have like the
Solution.
functions? Will they all be eight? Like, I
Polynomial.
mean,
the second
for the
half.
functions, you know, these functions we can just use our calculators to like find the root.